So, greetings and welcome, friends. We're talking yet again about dividing radicals. Remember the rule for radicals within fractions? What was the rule that mathematicians made? They said, never do this. What was the rule with radicals? Never have a radical in the bottom, or the denominator, right? The debottominator, right? All right? So that's going to be the same thing we have today. But let's consider, here's a consider problem. Consider, all right? So we know how to solve, like, get radicals out of denominators. I multiply by, like, square root of 2 over square root of 2 or whatever. What would we do if this 2 over 1 plus the square root of 3? What if this was the radical I wanted to get rid of? What is your thought? All right, we're going to try this problem a few different times and see what happens. What do you think I could do to try to get rid of that radical?
Did you square the whole?
If I squared the whole thing, that actually would result in squaring this thing, right? And squaring this thing, this is the square of a binomial. And squaring a binomial, a plus b all squared, gives me a squared plus 2ab plus b squared. And this b squared term would get rid of the square root. But the problem is I'd also have to plug the square root of 3 in right here. And it would actually reintroduce a square root. So that actually wouldn't work. The other error with squaring the whole thing is that by squaring the whole thing, I'm changing the value, right? Like, I want my next answer to be equal to this, not to be whatever that was squared. So squaring, like, both sides of an equation is a legitimate move. But if I'm simplifying something, squaring it probably is not. By 2 over 2?
Yeah.
That would be a fair move, but that would just double this. I'd just have like 2 plus 2 squared to 3. So that wouldn't get rid of the radical. But probably multiplying by some fraction over itself, because I am allowed to multiply by 1. What was your thought, Maddie? Yeah, let's try it, right? That would have been what we would have assumed based off of our previous skill set, right? What happens when I multiply by square root of 3 over square root of 3? Let's do this out. Let's just watch what happens here. I'd get 2 square roots of 3 up top over, and now beware, I have to distribute this to both of these. So square root of 3 times 1 is the square root of 3, plus the square root of 3 times the square root of 3 is the square root of 9, which is just 3. That's an ugly 3. That almost looks like it'd be like a bird, like a badly drawn seagull. I don't know. So, hey, I got rid of my radical, right? Oh no, it came back over there now. This is like whack-a-mole. Like I just like knocked that one down, and then suddenly like another one came up from another spot.
Wrecking ball.
Wrecking ball? Oh, I'm sorry. I'm not familiar with wrecking ball. So, what's your idea? What could I multiply by top and bottom? 9?
Yeah.
Well, that would just give me 9 plus 9 square roots of 3. So, what are your thoughts?
3 over 3. And then 3 and then get square root of 9.
Well, that would have been like this, which is what we just did a moment ago, but the problem is that it distributes to both. And whatever radical I multiply by is going to give me another radical. That would be 3 plus 3 roots of 3. And that wouldn't work out. By the way, a lot of times when someone sees something like that, they're like, oh, 3 plus 3 is 6. That's 6 roots of 3. And that's wrong. You can't do the addition before this multiplication that's implied there. Side note. It turns out I can't multiply it by one thing. I have to multiply it by 2 things. All right, so I'm going to multiply it by like a binomial. All right, so like something plus or minus. So what could I multiply by it? 2 things that would help out. And it's actually going to relate to our patterns.
1 minus the square root.
Oh, what? Check this out. 1 minus the square root of 3. Now, why is that? Why didn't you try plus? Well, Well, if it was plus, that would have been the same as a plus b times a plus b, or a plus b all squared. And we already considered that pattern a moment ago because that has the 2ab term, which I don't like, right? However, if I multiply by the, what are these called? They're not opposites, they're conjugates, right? So I'm going to multiply this by a minus b. And what's the beauty of this pattern? What's this equal to? Does anyone remember? Anybody? No?
AB's double parentheses squared.
No. A squared minus b squared. What is awesome about a squared minus b squared? Notice all of its terms are squared individually, right? So if I could have this squared minus that squared, squaring would get rid of square roots. And I wouldn't have accidentally introduced like some AB or 2AB term that would still have square roots within it. So clever move, friends, clever move. So let's multiply this out. So up top, I'd have 2 minus 2 square roots of 3. I'm fine with radicals up top, though. We don't care about that. And down on the bottom, I'm going to have to, once again, be careful with these parentheses. And if I'm multiplying a binomial times a binomial, double distribute, or, in this case, because they're conjugates, I can just jump right to this pattern. Minus root 3 squared, right? A squared minus b squared, a would have been the 1, b would have been the root 3. So let's simplify this. So 2 minus 2 roots of 3 over 1 squared is 1 minus, what is root 3 squared? 3. So I get 2 minus 2 roots of 3 over negative 2. Okay. Does anyone have any ideas on how to I mean, well, first of all, hooray, we got rid of that radical in the denominator. Now we're just like simplifying for the sake of simplifying. Does anyone have any ideas on how we could simplify this further? I'm going to take a sip of water. Well, a couple ways to think about this. You might remember back when we talked about dividing by a monomial. You could just break up each term by said monomial, right? Divide it out like that. And 2 over negative root 2, or sorry, negative 2 is negative 1. These two minus signs would cancel out. What would happen to these 2's? Yeah, so I just get negative 1 plus the square root of 3. Which, notice, has no denominator. I mean, it would have been fine if it did, as long as there was no radical in said denominator. So, wow, good call, friends. That was amazing. Amazing work. So, the other way, by the way, to simplify that is I like to sometimes draw like a little cactus or a heart, and I'll be like, oh, if I'm going to reduce by 2, I have to reduce every term by 2, and I could change this to a 1, this to a 1, this to a 1, and then I'd also have to figure out the sign thing. So there are some other ways you can do that simplifying step, but the easiest to understand is just break it up. You know, break it into 2 separate fractions or 3 separate fractions, whatever the case may be. So not bad, friends. I like it. I like it a lot. Let's do one other example. I think I can get away with just 2 examples today. Dos ejemplos. Yeah, this is going to be a nice short video compared to yesterday's. So let's say I've got the square root of 3 plus 2 over the square root of 3 minus 5. Man, I don't like that 3. 3 minus 5. And notice my care I took in making sure that this radical sign didn't get like too long and suddenly include the negative 5. It doesn't. All right. So looking at this, I can't just multiply by root 3 over root 3, right? Because it'd be the same thing where I'd have to distribute. So I'm going to multiply by the conjugate. What is the conjugate of the denominator? I like it. Good call. Square root of 3 plus 5. Yeah, good job. Good job, teamwork, cheering each other on. I like it, friends. So let's see what I've got. Up top, I'm going to have to consider that these vinculums are grouping symbols, so therefore these are both individual groups that are being multiplied. Up top, I have to, for real, double distribute. So let's see, root 3 times root 3 is square root of 9, which becomes 3. Root 3 times 5 is plus 5 square roots of 3. 2 times root 3 is plus 2 square roots of 3. And 2 times 5 is 10. Over. That's it. There we go. That's a little better. And in the denominator, the debottominator, I multiply those guys. And I could double distribute again, or better yet, let's use a pattern. I know A is the root of 3, B is 5. What's the pattern equal to? What's this equal to? A squared minus B squared. It's the difference of squares pattern that we memorized the other way back when we were factoring. So A is the square root of 3, so that'll be the square root of 3 squared. And B is 5, so that'd be minus 5 squared. By the way, this is always a minus sign here for this pattern, never plus. So you actually can choose 5. You could technically plug a negative 5 in here, but it still won't matter because that'd be positive anyway. So let's simplify this. Up top, let's combine like terms. 3 and 10 are friends. So that's 13. I like it. And do we have any other like terms? How did you know those were like terms? Same index and radicand. Guys, we are so awesome at this. So I've got 5 rutabagas and 2 rutabagas. How many rutabagas? 7.
But it's still a rutabaga, so you don't...
I love it. By the way, man, seriously, Super Mario 2, when like you'd be able to stand on a rutabaga and pull it up out of the ground and then throw it at people, you know what I'm talking about? That game was awesome. But my confusion is, how did Mario stand on top of an enemy and then pick him up over his head while he was standing on him? Like, imagine if like wrestlers could do that. Like, I'm going to stand on your shoulders and then grab you and pick you up over my head.
While still standing on the shoulders.
Well, at some point he stopped and then he'd fall to the ground. But it's just like, what? It's craziness. Craziness. Square root of 3 squared is 3. 5 squared is 25. Let's see. So equals 13 plus 7 roots of 3. Actually, I get it. Root a bega. Am I right? Root, like square root. Come on. Come on. Actually, I could write it as just this.
I had such a funny chemistry group today.
The root of bega.
Don't trust, don't trust atoms. They make up everything.
I like that. I like that. So guys, this is technically 3 and 7 can't partially cancel with 22. Would have been great if that was 21 though, but that's fine. However, just like radicals not in denominators, I'm kind of not a fan of having a minus sign in a denominator. So what I'm going to do, I'm just going to like take that minus sign and just be like, you go up there, you go away. And you just have to opposite every term in your numerator. So I'd rewrite this as negative 3 minus 7 roots of 3 all over positive 22. That's just like a cooler way to write it. Yeah. I mean, seriously, the denominator is already like on the bottom. Don't make it even more sad by leaving it negative. It's like, oh, poor guy. All right, so internet friends, today's lesson, kind of short, but the whole idea is if you have a binomial in the denominator and one of those terms in said binomial has a radical, which is a square root, you can get rid of that square root by multiplying the fraction by the conjugate over itself. Wow. I didn't realize how complicated that was going to be until I started saying it. And then halfway through I was like, this isn't helping, but that's okay. Maybe some verbal learners out there would be like, yeah, I understood all that. That makes sense. You're welcome. Bye-bye.